Okay, now we are going to the third level of an empiric formula, that is about experiment. So in an empiric formula and molecular formula, there is a two experiment that we need to learn. One, the experiment to determine the empirical formula of copper oxide. So now this experiment, our purpose of this experiment is to determine the empirical formula of copper oxide, and normally this method is being used. Okay, this method is being used for metal which is less reactive than hydrogen. Now when we talk about metal which is less reactive than hydrogen, it means I'm talking about the same procedure can be used to determine any oxide, empirical formula of any metal oxide which is below hydrogen. For example, like lead oxide. Okay, so before I could explain to you how to carry out the experiment, how to conduct this experiment, how to write the procedure, hypothesis, and so on. So I need to explain to you an introduction to this experiment. That means what are the precautions and steps to improvise this experiment. Now I'm starting with introduction for the experiment. Now I've given you here, the first thing I've given you here is the introductions for the experiment, is the arrangement of apparatus for the experiment. So to determine the empirical formula of metal which is less reactive than hydrogen, example copper oxide. Now when you do this experiment, we need to reduce copper oxide. Now if I want to reduce copper oxide can be reduced by hydrogen. Therefore I'm using hydrogen in this experiment. So whenever or any experiment in chemistry, if you are using hydrogen as a reactant, the first thing that you need to do is you have to prepare the hydrogen gas in a laboratory. Because in any of the laboratory, we are not talking about high-end laboratory, we are talking about our school laboratory. We normally don't have hydrogen tank. We don't have oxygen tank. Very rarely we have it. So what we need to do is we need to explain, or we need to prepare hydrogen gases before we can actually carry out the experiment, because the reactant is a gas. Secondly, we need to know how to produce a dry hydrogen gas. Now we have to do 3 steps here actually. Step 1 is actually for preparation of hydrogen gas. The step 2 is to prepare the dry hydrogen gas. And third, then only we're doing the reductions of copper oxide. Now, to prepare, to dry for the reactions of reduction copper oxide. That means we have to go through these 3 stages. So now I'm going to explain stage by stage what we need to do before we can actually rebuild the entire experiment altogether. Now we are going to do the next part. Our first problem in this section is how you can prepare hydrogen gas in the lab or laboratory. So any reaction between zinc and hydrochloric acid, that means any metal react with acid, it forms salt and hydrogen. The metal should be more reactive than hydrogen in order the metal can react with the acid. So the metal must be more reactive than acid, hydrogen. Therefore it can form hydrogen gas. And practically this is called as a chemical property of acid. Chemical property of acid, I call that as a comma. Only 4 chemical property of acids are there in our syllabus, and the 4 of them is called comma. That means this is called comma. The C stands for carbonate, O stands for oxide base, M stands for metal, and A stands for alkali. That means acid can react with carbonate, oxide base, metal, and alkali. This is the only 4 reactant that the acid can react, and one of them is metal, and that's the one we are using. Metal react with the acid to form salt and hydrogen, and this is a procedure to produce hydrogen gas. Now I'm using here as example here is hydrochloric acid. Student could use sulfuric acid or nitric acid if you want to. Okay, now then this is how we do zinc react with hydrochloric acid to form zinc chloride, that's called salt, and we will get hydrogen. So this is how we prepare hydrogen gas in the school laboratory. And I have given you an attachment of a video here for you to observe, and the video will explain to you how to produce a hydrogen gas in a school laboratory, followed by how do you know that the gas produced is actually an hydrogen. So that's the two things will be done. So here we will collecting the gas in a proper way, how we can collect the gas, and the first video we will explain to you the gas form is a hydrogen. So it means we're going to use wooden splinter to prove that the hydrogen gas is being produced. Okay, now this is the first section that you should know. Now let's go on to the next part. The next part of what we need to know is, I'm going part 1, that means the apparatus to prepare hydrogen gas. Now what are the apparatus? How are we going to prepare hydrogen gas in a school laboratory? The first setup is actually, you see here, I need a flat bottom flux. Then what I do, second things, I'm going to put a zinc pieces. You can put a powder form in order to increase the rate of reaction. Put inside the flat bottom flask. Then second step, what you need to do is you have to do 2-hole rubber stopper. Okay, 2-hole rubber stopper to be fit into the mouth of the flux, where each one we are putting connecting tube, and also the other holes we are putting diesel funnel. Okay, now this is what we set up. After that, the third step is we already put a diesel funnel and connecting tube, and 4 we're going to add in hydrochloric acid pour through the diesel funnel into the flux. Now once the acid is meet with the zinc, the both will react. That means zinc will react with the hydrochloric acid to form a salt, zinc chloride, and hydrogen gas will be removed, and hydrogen gas will be emitted out from the flux through the connecting tube. Now the hydrogen gas which is being produced, correct now, should be not allowed. Okay, see how we can avoid hydrogen gas from escape through the diesel funnel. How are you going to make sure that the hydrogen produced does not go out through the diesel funnel? To do that, what you need or required to do is you add the hydrochloric acid through the diesel funnel until the hydrochloric acid level is above the bottom tip of the diesel funnel. That means the end of the diesel funnel and the level of acid must be above. That means this must be below or immersed inside the acid in order to prevent the hydrogen gas which is produced to escape through the diesel funnel. Therefore, the hydrogen gas only escape through the connecting flux. Now we continue. Now the next level, the fourth things that we should know in this chapter, this experiment, is how you can dry up the hydrogen gas. Now to dry up hydrogen gas, the gas which is being produced is actually wet. It goes through a U-tube which is being filled up with a anhydrous calcium chloride. That means it's a dry calcium chloride. It's actually practically will suck the water from the hydrogen gas. Then it will dry the hydrogen gas and it will emit out on the other end of the U-tube. So you can use this method to dry the hydrogen gas. And sometimes, some questions, we don't use calcium chloride, anhydrous calcium chloride. We can actually use concentrated sulfuric acid. Okay, the next step is now we are doing the fifth level, where we are going to draw an arrangement of apparatus for the reaction between the hydrogen and copper oxide. Here we have a hydrogen gas coming into a test tube. This is called a combustion tube, and inside I put a copper 2 oxide, where it is been put inside an asbestos crucible. Now this is actually to make sure that the test tube is not being stick with the copper oxide after the experiment. So this is actually the preventions from the copper oxide to stick into the test tube, and the end of this test tube must have a hole for the excess of hydrogen to be burnt. So this is the diagram that we use to do the reduction reaction for copper oxide. the next step. See, hydrogen gas is a very explosive gas. That means it is a dangerous gas. We cannot emit to the surrounding. That means as the hydrogen gas go to the laboratory, the whole laboratory is filled up with hydrogen gas. If somebody open a fire, the entire laboratory will be exposed. Now, every dangerous gas that we are using, we should eliminate the gas which has been emitted. So one way of eliminating this gas which has been emitted is by burning the excess of hydrogen at the end of the tube. So hydrogen gas that exists through the end of the heating tube is lighted, so that this hydrogen will burn with the oxygen to form water, so that we have actually converted the gas to become a more safer gas as a steam. Now the next, why the excess of hydrogen gas is lighted. There's a few steps, a few reasons why we are doing this. One, to ensure a continuous hydrogen flow to the combustion tube. Two, to prevent the air from the surrounding to suck inside into the combustion tube. That means when they come inside, it can oxidize the copper that we found. And thirdly, to prevent excess of hydrogen gas fill up the laboratory, which can explode when it's exposed to the flame. These are the three steps or reasons that why we should burn the excess of hydrogen. And some of the precautions of this experiment. So precaution number one, okay, when excess of hydrogen lighted in the air, water form, and there is a possible it flow towards the hot asbestos crucible and crack the combustion tube or effect the mass of copper formed. So that means when the hydrogen which is burned with the oxygen forms water at this point, when it forms the water at this part, so when the water forms, the water will be forming somewhere here. Okay, and if you put it water here, the water can drip into the copper and it will affect the reading of the answer. Now, how we can overcome this problem, prevent this problem? So the combustion tube need to be slanted slightly towards the hydrogen flame. That means we push it this one a bit down. Okay, when you push it a bit down, so it will be slanting upwards. Then this will prevent the hydrogen, the water from the touching the copper oxide, and the water will be somewhere at the end of this test tube. Okay, now next, precaution number two. Okay, the precaution number two that we are going to look here is about when the hydrogen mixed with the air and ignited, it's going to form pop sound. If it's too much of hydrogen, it can form an explosion. So mixture of hydrogen and air can cause explosion when lighted. How to avoid this? So we should avoid this before we can burn or light it up at the end. So what we will do is the hydrogen gas must be allowed to pass us through the end of the heating tube for a few minutes, because the excess of hydrogen, then only the excess of hydrogen is being lighted up. This is practically will be done to remove all the air inside the heating tube. All the air in the heating tube will be removed by allowing the hydrogen passes through. Okay, the next step. Now another problem came in. How do you know that the entire gas in the heating tube is being removed? We can't make a prediction that it is already been removed, but we have to make sure it is been removed. So how we can do that is, the next step is how do you know that the entire gas inside the combustion tube is already expelled before excess hydrogen is lighted? So the answer is, collect the gas expelled at the end of the combustion tube. Now see, can you look at the diagram here? So there's a test tube here. Okay, there's a test tube here. So what do? You collect it. Okay, you collect at the end of the test tube, there's a hole there, collect the hydrogen gas as been shown in this diagram. So we collect the gas. Once we collect the gas, then you know what we do? We carry out a test. Okay, we carry out a test, repeat the step one until no pop sound is formed. So we test, see, we close the test tube with your finger, then you test with the burning wooden splitter. If the pop sounds form, that means you have to repeat again the experiment until there is no more pop sound. This indicates that the hydrogen gas, which is the gas which is emitted out from the test tube, is actually free from the air. Now you can light it up the end of the test tube. Now, the other precautions that you need to look into is a precaution number 3 here while carrying out the experiment is how do you know that reaction is completely reacted? That means the entire copper oxide is already been turned out to become a copper. So the process is, the answer is the heating, cooling and weighing process is repeated until a constant weight is obtained. That means repeat the experiment again and again until you get a constant weight. Then you are actually achieved the constant value, right? Therefore, the experiment is completed. That means the copper oxide already completely reduced. And the fourth precaution that we need to look into it is how you can avoid the copper metal from being oxidized again, because the copper is still hot. So it's very easily can react with the oxygen from the air to form a copper oxide again. So now we need to stop that. So how can we avoid that? So what we need to do is a continuous stream of hydrogen gas is allowed to pass through the tube until the copper is cold. Then only we take the measurement. Now, what is the chemical reactions? Copper oxide react with the hydrogen gas. It forms copper and water. Actually, at first it will be a gas. Water will be in the form of steam, and when it's condensed, it's become a liquid. Okay. So now this is the chemical reactions of a reduction of copper oxide. Since hydrogen is more reactive than copper, so you can actually reduce copper, and hydrogen can react with oxygen to form water, and copper oxide will be reduced to copper. Okay. Now you understood generally the basic requirement of the experiment. Now, to achieve the aim of the experiment. What is the aim of the experiment? My aim of the experiment is to find the empirical formula of copper oxide. Now, how I can achieve my aim? That means my aim is only going to achieve by analysis of data. So what I need to do in the analysis of data to achieve the aim? That means I need to know what is the mass of copper. I need to know what is the mass of oxygen that combine with the copper. Now, to do that, I actually stated here the tabulation of data. Now, we have a mass of combustion tube plus asbestos crucible is 8 gram. We have a mass of combustion tube plus asbestos crucible, and copper oxide is a B gram. And thirdly, we have combustion tube plus asbestos crucible, and copper is a C gram. That means if I take C minus A, so if I take C minus A, I will get the mass of copper. If I take B minus C, I'll get the mass of oxygen. That's why the mass of copper here, here is obtained by C minus A, which is X gram, and mass of oxygen combined with the copper will be B minus C, which is a Y gram. Now we use a table to determine the empirical formula. Element is the copper and oxygen. The mass of copper is X gram, oxygen is Y gram. Then we calculate the number of mole atom, which is X divided by 64 and Y divided by 64, and let's say the ratio is R and S. Therefore, the empirical formula of copper oxide is CuROS. By right, we will get copper oxide, CuO. But anyway, since we don't have all these values, therefore we will write an exam in this form. Okay. Now, what are the factors that we manipulated in this experiment? The variable that we manipulated here is the mass of copper to oxide that we used, and what is the responding the mass of copper that is formed. If you change the mass of copper oxide, that means you're going to change the mass of copper formed. And what are the other things that we are made it constant variable here? It's a type of metal oxide we use. We are using copper oxide here. This is the we have to use copper oxide, and also the hydrogen, we are supposed to use hydrogen as a gas to reduce the copper oxide. These two are actually the constant variables. Now, what is the hypothesis here? Hypothesis is practically written as hypothesis increase, responding variable is increase or decrease. It's conveniently to your question. For in this question, the manipulated variable is the mass of copper. That means the higher the mass of copper oxide is used, the higher the mass of copper formed. So this is the manipulated manipulated variable, and this will be the responding variable. So these two are related in increase and decrease. And lastly, we are talking about inference. In this case, this is an experiment inference. That means we are saying that the mass of copper oxide used in this experiment is influenced by the mass of copper formed. So this is the inference, hypothesis, and variables. Without knowing the variables, we can't determine the hypothesis. Without knowing the variable, we cannot determine the inferences. So the variable need to be found first before we can state the hypothesis and inference in any experiments in examinations. Now we are going into the next step. This is where we come into the procedure. Now the procedure and the experiment was carried out in an experiment in the laboratory, and it's been attached in a video here. So watch the video for the experiment that's carried out in a laboratory. And this is the setup apparatus where we prepare the hydrogen, we dry the hydrogen, and we reduce the copper oxide to become copper. So this is the apparatus. Now secondly, we need to explain how to do this. Then here, first thing what I'm doing after set up the experiment is, you see the combustion tube with an asbestos crucible is in it is weighted, and the weight is recorded. Now I have a crucible, inside a combustion tube, and I weighed it, and I got the mass as A and record the reading. Now after that, what you do, you take a spatula of copper oxide powder, is placed in the asbestos crucible and weighted again, and the weight is recorded. Now when you do that, your weight of copper oxide with combustion tube and asbestos crucible will be read. Then we are going into the next step. Okay, the apparatus is set up as shown in the diagram. Then hydrochloric acid is filled inside into the conical flask which contain the zinc, and make sure the volume of acid above the level Y, as I explained just now, so that the hydrogen does not escape through here. Okay, hydrogen does not escape through here. Then followed by, we need to dry the hydrogen gas and pass through the tube which for a few minutes to expel all the air from the combustion tube. Once you have done that, then only we heat it up or light it up, the excess of hydrogen. Now when you heat it up excess of hydrogen, then you heat it up the copper oxide. When you're heating up the copper oxide, correct now? So we need to continue this process until all the copper oxide is reduced to copper metal. That means the copper oxide color is black and copper color is brown. So once all the black color turns to brown, then the heating process can be stopped, and this is how it look like, the black color here, and this is how the experiment look like as a brown color here inside the test tube. Once you achieve this, you stop and allow the hydrogen to pass through. You see a continuous stream of hydrogen gas, okay, is allowed to pass through the tube until it's cool, and the heating tube is with its content is weighted, and the weight is recorded. And this process is been repeating. The heating and cooling and weighing process is repeated until a constant weight is obtained. Once you've done that, now you have actually obtained all the requirement that you needed for your tabulation of data and do your calculations. Okay, then only we write all the apparatus that required. Okay, Bunsen burner, retort stands, and stopper, and so on. So you can go through the notes here. And then make sure you write every single thing you use, and one is for apparatus and one for the material. For example, the material required for this experiment is a hydrogen gas, copper 2 oxide, anhydrous calcium chloride. So this is the chemical that we used in the experiment. And the apparatus we use is a Bunsen burner, retort stand with a clamp, U-tube stopper, combustion tube with a small hole at the end, electronic balance to measure the mass, spatula, glass tube, thistle funnel, and asbestos crucible. They are the apparatus. Now we can conclude that, okay, the empirical formula of copper oxide is CuO, and this shows that even the higher the mass of copper oxide you use in experiment, the higher the mass of copper will be formed with the actual sample mole atoms ratio is still the same. Therefore, we can say that hypothesis has been accepted and we have actually completed the experiment. experiment. Thank you.